Okay guys, welcome back to my YouTube tutorial on Smarter R. So today we will discuss how to calculate and mapping dry sequence during wet season in Senegal. So this is some of the framework of study on rainfall pause in Senegal. Last time in my previous tutorial, I already show you how to calculate the dry sequence under different categories. There's four categories that we calculate, and we also calculate the onset and the offset of the uh, wet season in Senegal. So based on that onset uh, and the end of the wet season, we calculate dry sequence during the wet season. So we already calculate that one, and there is some some calculation for mapping that we need to recalculate again because last time I'm doing for random grid. So actually, there is a grid point there. So we will calculate that one, and there is another extra calculation also. I will show you. So let's share the screen. This entire screen. Okay, share. So I already have prepared the R code for this one. So last time we already calculate the intra-seasonal dry sequence with 1 millimeter threshold for four categories, for 2 to 3 days dry sequence, 4 to 6 days dry sequence, 7 to 15 dry sequence, and the max sequence uh, ever happened during that wet rainfall season. Now we calculate the annual total for each of these categories. So this is just some of the temporal analysis. We want to calculate the annual total for each category so that we can make analysis in terms of temporal annually for each of these category. So we use the player library and read your the player library here, and then read your working address. So your working address is here. You copy this folder address. So we call it working address. Set WD means set working directory. Okay. So copy your folder address here and then read your data. So we use our previous data set, which is intra-seasonal dry sequence threshold for 1 millimeter for this input data that we have. So I close this one. So last time we already calculate this one, which on each grid year and each of these four dry sequence, right? And then now we want to calculate for each year. So we calculate the annual total for each category. So to calculate for annual total for each category, you calculate the dry sequence for annual total here, group, summarize here, calculate, and then just follow using this code, using sum total. I think total max sequence you can use min, not sum, min. It's better for max sequence to use min because we only get the max happen during each year. So it's better for each grid point you calculate the min. But for another category, you calculate the sum so that it will reflect more on the intensity of the dry sequence. And total max is because we not calculate how many times it's happened, right? We just calculate on that year what is the max ever happened. So we calculate the mean. So and then we print the annual total, and then we calculate annual dry sequence total. So you will get this annual dry sequence total. But total max is here. We calculate is actually sum. Uh, uh, Not sum. It's not sum here. We calculate. It's supposed to be mean. We run this again. Mean, and then run this one, and then get another. I make a revision for that code just now. We run it again, and then we get this total. So we see over all of that grid point how many total of 2 to 3 day sequence is happening for the whole of Senegal for this year. this year. But max sequence, we calculate how long. We take the mean only instead of total. So it's more reasonable calculation. Don't max sequence. Don't try to calculate the total. Try calculate the mean of it, average. Okay. Okay. Now we get this result. This very nice result. So over the years, we can see, for example, here we can see does the pattern seem for dry sequence doesn't seem to be change much. Maybe we look at more another. This is decreasing, and then another category. Let's see. Yeah, another category. This is the pattern of it. I don't know it's significant increasing or decreasing. I don't know, but we can see the pattern. This is the pattern. I think Mexican seem to be increasing a little bit here, maybe, but we can look linear regression. But this is just using Excel. Everybody can do this one themselves. It's very easy. You see that kind of increasing, something like that. But doesn't matter. We are not calculating this one. If you want to do this to know the pattern, everything, there you can calculate it yourself. It's easy. So this is the value that we have for all of this sequence for temporal one. So now we want to map the result, right? So first we arrange the grid sequence numerically for this data set right now, right? Just now, right? We previously we get this result, but the grid is not arranged from 1 until 269. So it's actually, we call it, this one is arranged lexogenically, but we want to arrange it numerically. So from V1 until V263 numerically. So we must arrange it properly first. So use library dplayer, read R and string R, and then read the dry sequence for this input dataset, and then extract numeric part of grid and convert to integers, and then handling the missing value. So use this result and use this code, and then we sort the dry sequence, and print head just to check the data set. But you can see sort dry sequence output will be there, sorted dry sequence. So now it's arranged from V1 until 263 properly. Now it's arranged very properly. Now it's arranged properly. Next is we calculate the annual total for each category, for each grid for mapping. For each grid, we must get the annual total for each grid, because now we want to calculate each grid so that we can mapping the grid. So we have data set for 1981 to 2019. We take the mean for that one, for spatial mean. We call spatial mean. So use library dplayer, read R, library string R, and then dry sequence, sorted dry sequence, the output, the new output that we have just now, sorted dry sequence that have a grid arranged in numerically. And then convert grid to numeric for proper sorting. So we do this again because sometimes if we doesn't do with this one, the grid will arrange lexically. So we want it numerically. And then summarize total for per grid. Sum, and but the mean sequence, we calculate the mean, not sum. We calculate everything just like before. We take the sum for the dry sequence for each grid, but for max sequence, we take the mean. And then we export the result and then print the data that just to check is the result is there. Now we have the output total dry sequence per grid mean. Per grid mean. This one. So now we have for each grid how many time from 1981 to 2019 this category of dry sequence happened. So now we can get this kind of result. So now we have grid input data, right? This is the grid input data for that corresponding for each of that V1 until V100 263, right? So I just put a new column here, and then just put your let long, long and let here in this data set. Just put long and let data set. So we will just use this input data set in the next analysis. So I already prepared that one actually for this one. It means I just put the grid let long here, here. That's why we arrange the grid from V1 until 263 properly just now, because we want to put this let long copy directly into your data set, and then we have the each of this category. Now we want to map. Now easy to map because the let long is already here. Now we can map this data, this category by easily. Now this is another extra. We want to. This is good for your study area. You can grid location over Senegal. So we use ggplot2, our natural earth, and our natural earth data. If you don't have this library, install this library. So we have grid send, right? This is the grid that was given to me, long and late for Senegal. And then you read that CSV file for Senegal, and then load the Senegal map from our natural earth. So you don't need to prepare your shapefile from ArcGIS or something like that. You can just use a shapefile from our natural earth. And then you create the map. You plot the grid point on the map. Grid point from grid send just now. Grid plot it on the Senegal map. So we use like gray. You can change the color here or whatever if you want, or some description of the map here you can change. It's up to you because it's something subjective. So this is the grid location for Senegal, for CHIPS dataset in Senegal. You can put this one in your study area. So you can see about 263 grid point in Senegal or something like that. You can describe in your study area section. So you can copy this, copy and put in your paper. Now we want to map this new data set just now, right? We want to map each of this category, and there is let long. This new data set, we input this let long also, and there's grid, but actually we don't need really that one. So we use ggplot2, our natural earth, our natural earth data, and also library scale for custom scale. Now we input this new data set we have just now, new data set which have grid, let, long, let, and 4 of that category. So read that CSV file, and then also read the map file for Senegal from our natural earth, Senegal, and then use this function to plot the map, plot category. So we use black. I'm using blue to yellow. So blue is very low dry sequence, and yellow is very high dry sequence. So it's yellow usually reflects with very dry condition. So easy for people to see the map, and they understand that area is very dry. Blue usually reflect with high rainfall. I already changed the color with dark blue, red, or something like that, but the best color is blue to yellow here. And you can change the title or whatever, is up to you. And then you run this code, and then we plot one by one. So the first category here, you see, this is the first category. So you can see this is the result for the first category. It's up to you. You can stretch or unstretch, and you can see the plot is become thicker or not. Dot here is up to you to do that one. But you can use this, copy this map, and then put it into your paper. You see the blue one have very low dry sequence over the years, but the highest dry sequence occurrence, this is dry sequence occurrence for this category. I don't know what you will call this 2 to 3 days, or you can call it low dry sequence or high dry sequence, medium dry sequence. I don't know. It's up to you. But this will be the mapping for that area. You can see the southeast is quite dry here, and this area also in the middle here is quite dry, and the southwest is quite not, the sequence is not very frequent. And then second category, this is the second category, and then this is the third category. You see the dry sequence because the become very rare for the third categories because 7 to 15 days is very rare, but the sequence can be very high in the northern area, something like that, northwest, and some patch of area, something like that. And then for maximum category, you can get this result. So make you can change whatever you want to describe the legend here. You can change here like mean of maximum dry sequence length, or you can put whatever the abbreviation that you have for that, for this one, MDS or something like that, so that easy for you to put into the legend later on. Otherwise it's become too long, right? But it's okay, you can stretch this one and then the result will be there. So you can copy this and put it into your paper. Okay, I think that's all for today. Thank you for watching. Refer for this tutorial and also for my previous tutorial to get this more information that how we calculate the dry sequence during rainfall pause. Okay, thank you for watching.